Welcome to section 9.5, the distance formula. The objective is to use the distance formula to find the length of segments. For homework, we're going to be working on page 394 to 397, 8 to 26, the evens. So first we have to know that the distance formula is derived from Pythagorean's theorem. So let's derive it. Let's say we want to find the length of AB, and A is at x1, y1, and B is at x2, y2. Well, let's draw that out. So first thing let's do is let's make a coordinate plane. I'm going to put my A up here, and I'm going to put my B down here. They have different x's and different y's, and we're looking for this length. Well, if it's derived from Pythagorean theorem, we're going to need to make a right triangle. So let's go ahead and let's form a right triangle using a vertical line and a horizontal line in order to make that. Now, if A is going to be at x1, y1, and B is going to be at x2, y2, let's find the length of these two sides right here. Now, imagine this was going to be 0.27, and this was going to be 0.51. Now, how would I find the distance that we traveled down if we're going from 7 down to 1? We would be subtracting it. Now, we don't know that this is 7, and we don't know that this is 1, but the process is still the same thing. The length of this side right here is going to be y1 minus y2. Now, same thing with the x's. To figure how far we went horizontally, we would go from 2 to 5. We would be subtracting them. So here we go. x1 minus x2. Now, if we plug that into Pythagorean's theorem, where our length is our c squared because it's our hypotenuse, what we would have here is we would have x1 minus x2 squared plus y1 minus y2 squared equals our c squared. Now, we got nothing to combine here, so instead we'd be square rooting it. When I square root everything, squares and square roots cancel out right here. The problem here is this plus sign. This square root can't cancel out with these squares because we have binomials. So it stands that our formula for our length is going to be the square root of x1 minus x2 squared plus y1 minus y2 squared. So our distance formula theorem says that the distance between any 2 points on the coordinate plane can be found using the following equation. The distance equals the square root of x1 minus x2 squared plus y1 minus y2 squared, or delta x squared, which means change in x squared or subtraction, plus delta y squared. So now we're going to find the length of AB with the given coordinates. So here we go. For our first one, A, which is our first pair of xy, is 3, 2. We're going to call that x1, y1. Our B, our second, we're going to call x2, y2. And let's plug it into our distance formula. The square root of x1 minus x2 squared plus y1 minus y2 squared. Two negatives make a positive. And let's clean that up. This gives us the square root of 6 squared plus negative 2 squared. If you're using a calculator, please make sure that you always have those in parentheses or else the calculator won't read it right. Clean it up a little bit more. That gives us 36 plus 4, which is the square root of 40. And let's simplify that. The biggest perfect that goes into 40 is 4. It's 4 times 10. And let's square root. The square root of 4 is 2, square root 10. Now you try and do that second one. Press pause and let's see what we can do. So here we go. Let's plug it in. The square root of 5 minus 8 squared plus 3 minus 7 squared. Now, would it be wrong if you flip-flopped it? If you did 8 minus 5 squared and 7 minus 3 squared? Absolutely not. You'd end up with the same answer because we're squaring it, so it always becomes positive. So here we go. Let's clean this up. We get negative 3 squared plus negative 4 squared, which is the square root of 9 plus 16, which is the square root of 25, which is a perfect 5. Now, that third one we're going to do slightly different. Although the distance formula works great, I actually like to use Pythagorean's theorem. So I'm going to draw kind of an off graph. So here's point A, which is at negative 5, 2. Point B, which is at negative 1, negative 3. I'm going to connect them. Now I'm going to go ahead and draw in that right triangle, just like how we would derive the Pythagorean's theorem. The horizontal distance traveled from negative 5 to negative 1 is going to be 4. The vertical distance between 2 and negative 3 is 5. We're looking for x. I'm going to plug it into Pythagorean's theorem. 4 squared plus 5 squared equals x squared. Where this piece right here was the change in x. This piece here was the change in y. That gives me 16 plus 25 equals x squared. Clean that up. 41 equals x squared, and let's square root it. No perfects dividing evenly, so x is going to be the square root of 41 for our distance. Either way you want to do it is fine. I actually like the Pythagorean theorem, but distance formula is actually a nice easy formula where we can always get our solution. So here we go. Let's find the length of the median from S to HO. First and foremost, if it's a median, that means it's going to be meeting at the midpoint. Let's find out what that midpoint is. Add up the x's, 12. Chop it in half, 6. Add up the y's, 8. Chop it in half, 4. So we're looking from the length from S to K. Either use Pythagorean's theorem or the distance formula. I'm going to use the distance formula here. Here we go. x1 minus x2 squared plus y1 minus y2 squared gives me the square root of negative 12 squared plus negative 7 squared. Remember, anytime you're squaring a number, it always comes out positive. That gives us the square root of 144 plus 49, which gives us the square root of 193. And let's think, is there any perfects that divide into 193? Absolutely not. So there we go with our answer. And here's our last example for this section. We're going to try and prove that the median to the legs of the isosceles triangle are congruent. Now, we're not going to do a 2-column proof here. We're actually just going to show our work and write a little bit to support that work. Now, if we're talking about medians, once again we're talking about midpoints. Now here is the point 0, 0. So we have to figure out what the midpoint is of those legs. So here we go. Add up the x's, 2a. Chop it in half, a. Add up the y's, 2b. Chop them in half, b. On this side, let's add up our x's, 6a. Chop it in half, 3a. Add up our y's, 2b. Chop it in half, b. Now, we have to find the lengths of those. So here we go. Here's my first one. We want to find the length of the median, so let's plug it into our distance formula. x1 minus x2 squared plus y1 minus y2 squared gives me the square root of negative 3a squared plus b squared, which is the square root of 9a squared plus b squared. That's going to be the length of my first median. My second median, let's draw it in. Let's find that distance. The square root of x1 minus x2 squared plus y1 minus y2 squared. That gives us the square root of negative 3a squared plus negative b squared, which is the square root of 9a squared plus b squared. And here we have a coordinate proof. So we used our coordinates to show that the lengths of those medians in an isosceles triangle are congruent to each other. So let's go ahead and say that. The lengths of the medians of the legs are congruent. And we're set. So here's our homework answers. Again, our homework is 8 to 26, the evens. So we're kind of working our way through the difficult ones. If you have any questions, make sure you bring it to class tomorrow. And as always, have a good one.